systems of equations. So to begin, the first one is asking us what the order of this matrix is. Remember to name an order. We're gonna go rows by columns. Rows go across, columns go up and down. The way I think of it is columns usually hold things up. So I'm going to count 1, 2, 3. So I have 3 rows. 1, 2, 3, 4, 4 columns. So this matrix C is a 3 by 4, and that is the correct order of the matrix. The next one, it says write the augmented matrix for the system of linear equations. So remember when you're doing an augmented matrix, the first row is equation 1, then equation 2, then equation 3. The first column will be my x's, then my y's, my z's in this case, and then finally over here will be my answers. So when I write this matrix, see, I'm going to have 1, 10, -2. Put those 3 dots to separate your coefficients from your answers. 2, then 5, -3, 4, dot, 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 0, then 2, 1. I don't have a y, so that's understood to be 0, 6. And that is my augmented matrix. Augmented matrix means that I have the coefficients along with the answers. Write the system of linear equations represented by the augmented matrix. Use the variables x, y, z, and w if applicable. Well, we just have an x, y, and z here. So I'm going to have 9x plus 12y plus 3z is equal to 0. -2x plus 18y plus 5z is equal to 10. And finally, x, and you can write 1x if you want, but I'm just going to write x, plus 7y minus 8z is equal to -4. And there is a system of equations represented by the augmented matrix. The next one, it says they want you to look at the original matrix and they want you to compare it to the new matrix and say what you did. So when I look, 4, -5, 1, 3, that stayed the same. Then I have -1, 1, -7, 3. Well, that appears to have gone to the first row. And it appears that the first row went to the second row. So I'm going to say I switched row 1 and row 2. I just switched the places. And there's lots of reasons why you would do that. The next one, perform the sequence of row operations on the matrix. What did the operation accomplish? So the first one says that I'm going to add -2 times row 1 to row 2. So -2 times row 1. So row 1 is at 1, 2, 3. So I'm going to -2, -4, -6. That's -2 times row 1. I'm going to add it to row 2, which is 2, -1, -4. And when I do that, I get 0, -5, -10. So right now, after step A, I have a matrix C that's 1, 2, 3, 0, -5, -10, and I didn't change my third row at all. And what did that accomplish? That eliminated the X in row 2. Then the next thing they want me to do for part B is they want me to add -3 times. So now I'm on part B, -3 times row 1. So I'm going back up here and multiplying that by -3. So -3, -6, -9. And I'm adding that to row 3, which is 3, 1, -1. And when I do that, I get 0, -5, -10. That looks familiar. So 1, 2, 3, 0, -5, -10. I didn't touch those two at all. And then this is my new row 3. And what did that do? That eliminated the X from row 3. C, multiplying -1 times 2. So -1 times row 2 will be 0, 5, and 10. And when they say row 2, they want you to go to the new row 2 and add row 3, which is 0, -5, -10. And I get zeros. What did that accomplish? That eliminated the Y and the Z from row, and we're going to put that in row 3. So now what I have is 1, 2, 3, 0, -5, -10, and then 0, 0, 0. And that's after step C. And then step D, multiply row 2 by -1/5. So I'm going here, and I'm multiplying that by -1/5. So that'll be 0, 1, 2. So I'm going to have 1, 2, 3, 0, 1, 2, 0, 0, 1. And what did that do? That gave me a lead coefficient of 1. Remember, lead coefficient is the first non-zero entry in a row. So that changed this -5 to a 1. And that's what I want for row echelon form, is I want those lead coefficients to be 1. Then it says add -2 times row 2. Ooh, -2 times row 2 to row 1. So I'm going, oh, that was D, and now we're on E. -2 times row 2. So 0, -2, -4, and I'm adding that to row 1. 1, 2, 3, and it'll be 1, 0, -1. So now I'm going to be left with 1, 0, -1. 0, 1, 2, 0, 0, 1. And what did that do? That made this a 0, so I'm headed towards reduced row echelon form. And that is the answer to that one. Number 33, write the matrix in row echelon form. Remember that row echelon form is unique. So I'm going to follow that pattern that we learned for matrices. I'm going to do row 1 and row 2 to eliminate the X, then row 1 and row 3 to eliminate the X, showing all my steps. So I'm just going to add row 1. And if I add it to row 2, since they're already opposites, that's going to eliminate the X. So I'm going to have 0, -6, 3. And I'm going to write a new matrix for when I eliminate my X's. And so I'm going to write that here. So the row 1 stays the same. Row 2, I just made that. And now in order to eliminate this X here, I'm going to multiply row 1 by a -2. So I'm going to have -2, -4, -6, 0. I'm going to add row 3, which is 2, 6, 3, and 10. When I add those, I'm going to have 0, 2, -3, 10. 0, 2, -3, 10. Again, row echelon form means that the first non-zero is a 1, and everything below that is a 0. If that makes sense. That makes sense to me. I hope that makes sense to you, else we're in an awful lot of trouble. So when I did that, I got that, and now I'm going to work on, I'm going to follow that same pattern, and I'm going to do row 2 and row 3 to eliminate the Y. So it looks like I can leave row 2 alone and multiply row 3 by a -3. So -3 times row 3 will be 0, -6, +9, -30. And then row 2 will be 0, 6, 3, and -5. And when I add those, I'm going to get 0, 0, 12, -35. So I want to put that in for the last row, but before I do that, I want the lead coefficient to be a +1. So I'm going to divide both sides by 12. And I know it doesn't simplify, and I'm okay with that. So I'm going to end up writing this as 0, 0, 1. Oh, it didn't have the dots. I'm so used to doing the dots. And then -35 over 12. So that has the requirements for row echelon, which means I have the first non-zero as a 1, and then I have the answer, whatever that is. So if I want to just put in row echelon form, this lead coefficient is already a 1, so I'm going to leave that the way it is. And then the last thing I have to do is I have to make this 6 a 1. Well, the easiest way to do that is to divide row 2 So if I take my 0, 6, 3, and negative 5, and if I, that's my row 2, and if I just divide it by 6, I'm dividing everything by 6, then I'm going to end up having 0, 1, 1/2, and negative 5/6. And that is in row echelon form. It's not in reduced row echelon form, but it is in row echelon form. And what row echelon form does is it allows me to back substitute. I can leave it like this and call it a day. I am done. Row echelon form, just to like drill this into your heads, you have this lead coefficient column of ones. Everything below that is a 0. That's row echelon form. So going way off on a tangent here, but here I go. Um, I could, at this point, I know that z is equal to negative 35 twelfths. And then the line above it would be y plus 1/2 z is equal to negative 5/6. Well, I could just simply substitute this in, get my y, then substitute them both in. So that's the advantage of row echelon form, is it allows me to find my z, then go back and find my y, then go back and find my x. So if you check the back of the book, multiple different answers, and they're all correct because eventually they'll get you to the same place. But this one just wanted me to put in row echelon form, and I'm done. So I'm stopping and I'm moving on to the next one. Okay, the next one says write the system of linear equations represented by the augmented matrix, then use back substitution to find the solution. So this one is what we just talked about. It has the lead coefficients of 1. Everything below those lead coefficients in the matrices are zeros. So this is where it would be a great time to stop and use back substitution. So if I use back substitution, I'm going to, well, first I'm going to write the system. It's going to be x minus y plus z is equal to 4. Then I don't have an x, but I have y minus z is equal to 2. And then finally, z is equal to negative 2. Now I'm going to back substitute in. I'm going to take this negative 2 and put it in here. So I'm going to have y minus z, which is negative 2, is equal to 2. So I'm going to have y plus 2 is equal to 2. Y is equal to 0. Putting both the 0 and the negative 2 into the top equation, I'm going to have x minus y, which we just said was 0, plus z, which we said was negative 2, is equal to 4. Oh, that's a 2z. 2z. So I'm going to have x minus 4 is equal to 4. Add 4 to both sides, and x is equal to 8. So my ordered triplet is going to be 8, 0, negative 2. And that is my final answer for my x, my y, and my z. Life was so much easier because I was in that row echelon form. Now, 55 says use Gauss-Jordan elimination. So now, Gaussian elimination and Gauss-Jordan elimination sound the same. Gaussian elimination is this. You get it to this point, and then you can back substitute in. Gauss-Jordan, two different guys. They came up with the whole reduced row echelon form. And that means I have to have that main diagonal of my coefficients as ones, and then everything else should be a 0. And that way I know exactly what my x is, my y is, and my z is. So going back to those patterns that we did on 7.3, I'm going to do every single step. I'm not going to stop and back substitute in. Yes, I know you can back substitute in, but that's not the point of this problem. All right, I'm putting this into matrices. So I'm going to have 1, don't have a y. I like to put those dots to separate my answers from my coefficients. I'm a huge fan of that. So there, whoopsie, that's not what I want to do. So there's my augmented matrix. Oh, for the system of equations that they gave me. Following that pattern, I'm going to do R1, R2 to eliminate my x. So R1, it looks like I'm going to have to multiply by a negative 3. So this will be negative 3, 0, positive 9, positive 6. Copying down row 2, I'm going to have 2. Oh, no, I'm not. I'm going to have 3. 3, 1, negative 2, 5. When I add, the 3's will equal 0. 1, 7, 11. So I'm going to write that down. 1, 0, negative 3. And then 0, 1, 7. And now I'm going to do, to eliminate this x here, I'm going to do negative 2 times row 1. So negative 2, 0, positive 6, positive 4. Adding row 2, I'm going to have, sorry, 2, 2, 1, and 4. When I add those, I end up with 0, 2, 7, 8. The next thing I'm going to do is I'm going to combine rows 2 and row 3 to eliminate the y, and that'll also give me my z. So look to eliminate these two. It looks like I'm going to multiply row 2 by negative 2. So 0, negative 2, negative 14, negative 22. Row 3 will be 0, 2, 7, 8. And when I add those, I'm going to get 0, 0, negative 7, negative 14. Well, when I get to this point where I have the two zeros, I'm going to divide by whatever this number is. So in this case, I'm going to get 0, 0, because 1, and then 2. So now I found z. My z is 2. But remember, and I could back substitute in, because when I write this, I am going to be in, just because of the way I lucked out, this is in row echelon form. I could back substitute, but that's not what the directions are telling me to do. They're telling me to do full Gauss-Jordan elimination. So now I'm going to do row 2 and row 3, but this time I want to eliminate this z. So it looks like I'm going to multiply by negative 7 times row 3, which is what I had up here. 0, 0, negative 7, negative 14. Copying down row 2, this will be 0, 1, 7, 11. So I'm going to have 0, 1, 0, negative 3. So this is what I have, row 3. And then row 2 is good. And now I just have to fix row 1. So according to our chart, we're going to do row 3 and row 1 to eliminate this z right here. So it looks like I'm going to have to multiply row 3 by a positive 3. So 0, 0, 3, 6. And then row 1, whoopsie, I lost it, is 1, 0, negative 3, negative 2. And when I do that, I get 1, 0, 0. And I kind of lucked out there, because I do not have to do that last step of doing row 2 and row 1 to eliminate this y, because that y was already a 0. Just making sure. My main diagonals of coefficients are all 1s. Everything below those 1s and everything above those 1s on the coefficient side of that matrices are 0s. That means I know my answer. I know that x is equal to 4, y is equal to negative 3, z is equal to 2. So my ordered triplet will be 4, negative 3, 2. Okay, I'm sure we're going to do another one. It says use matrices to solve the system. A Gauss-Jordan elimination. It says if possible, because if you ever get an entire row of zeros, that means there's no solutions. So I'm going to first write the augmented matrix C for this. So that's going to be negative 1, 1, negative 1. So there's my augmented matrix C. I am going to go through that pattern. So to eliminate this x, I'm going to multiply row 1 by 2. So I'm going to have negative 2, 2, negative 2, negative 28. Then row 2 is going to be, and that's just me putting a dot there like a check or whatever, I don't know. 2, negative 1, 1, 21. And when I add those, I get 0, 1, negative 1, negative 7. So I'm going to take the time to write down. And then to eliminate this 3 here, I'm going to multiply row 1 by a 3. So 3 times row 1, so negative 3, positive 3, negative 3. And then this will be negative 42, row 3, 3, 2, 1, 19. So 0, 5, negative 2, whoops, and negative 23. The next part of my pattern is to do row 2 and row 3 to eliminate the y. So it looks like I'm going to have to multiply 5 times row 2. So 0, 5, negative 5, negative 35. Oh, it's going to have to be negative, isn't it? Negative, positive, positive. And then row 3 will be 0, 5, negative 2, negative 23. I just want to make sure that when I add their opposites and I don't have to worry about subtracting. So 3, and then this ends up being 12. I've gotten to this point where I have 2 zeros, which means I'm finding my z. Whatever this is, I'm dividing both sides by that. You're technically dividing everything by, but divided by anything is still 0. So I'm going to end up with 1 and 4. So now my last row is going to be 0, 0, 1, 4. Then 0, 1, negative 1, and then negative 1. Okay, the next part of the pattern says that I do row 2 and row 3 to eliminate this y. So it looks like that's just going to be a straight addition. So I'm going to take row 2, which is 0, 1, negative 1, negative 7, and I'm going to add row 3. And when I do that, I get 0, 1, 0, negative 3. So I'm almost done. Don't lose faith. We're almost there. So I'm going 0, 1, 0. Now I am going to do, the pattern says to do row 1 and, oh, I should probably write row 1. Sorry, my bad. Oh, and that's, messy, messy, messy. Let me clean it up. So that's negative 1, 1, negative 1. Okay, negative 14. So the next part of the pattern says in order to do this, I take row 1 and row 3, and I'm eliminating this z right there. And it looks like, again, that's just straight addition. So let's make that happen. Row 1 will be negative 1, 1, negative 1, negative 14. And row 3 is 0, 0, 1, 4. And when I do that, I get negative 1, 1, 0, negative 10. And then I could, yeah, all right. And then the next thing I'm going to do is I'm going to take row 2 and row 1 to eliminate this y. And I am actually going to multiply row 1 by negative 1 because I'm going to have to multiply it by negative 1 eventually. So let's do that. So negative 1 times row 1 will give me a positive 1, negative 1, 0, 10. And then row 2 will be 0, 1, 0. And now I end up with 1, 0, 0, 7. If you did not multiply, if you multiplied this by reverse, then you would have had a negative 1 here and negative 7. You would have divided everything by negative 1. You're still going to end up with 7. So there's my reduced row echelon form. I have the main diagonals of 1s. Everything else on the coefficient sides are 0s, which means this last column here is my answers. So my order triplet is going to be 7, negative 3, and 4. X is equal to 7, Y is equal to negative 3, Z is equal to 4. Okay, and the last one I believe is a word problem. So a small corporation borrowed $1 $1,500,000 to expand its line of shoes. Some of the money was borrowed at 7%, 8%, and 10%. Use a system of equations to determine how much was borrowed at each rate if the annual interest rate was $130,500. The amount borrowed at 10% was 4 times the amount borrowed at 7%. So I'm going to say X is the amount at 7%, Y is the amount at 8%, and Z is the amount at 10%. So my first equation is how much money I borrowed. Well, I borrowed X, Y, and Z, and that's a total of $1,500,000. The next one is based on the equation. So to find the interest for this, I'm going to take 0.07 times X plus 0.08 times Y plus 0.10 for Z, and my interest was $130,500. The last equation is the amount borrowed at 10%, that's Z, was 4 times the amount borrowed at 7%, which is X. So to set these equal to each other, I'm going to have to multiply that X by 4 to do that. 4 times that amount will give me Z. Now, the problem is I have to, so I'm going to write that here. No, I'm not going to write that there. But now I have to, in order to do this, I have to I have to put it so it's set equal to 0. So what I did, and I don't know why I did this, I said 0 is equal to negative 4x plus z. And I don't know why I went that way, but I did. So this is negative 4x plus z is equal to 0. You could have 4x minus z. So you're going to have the same thing as the answer, just a little few different steps. What really bothered me is I don't really want to multiply by 0.07 and 0.08. So what I decided to do is I multiplied all these by 100. Because if I multiply them by 100, I'm going to have 7x plus 8y plus 10z. I'm multiplying by 100, so I'm adding 2 zeros. So that gives me 7x plus 8y plus 10z. I thought that was easier than multiplying by decimals. If you kept the decimals, that's fine. I did not. So my matrix now is going to be 1, 1, 1, and then 7, 8, 10, and then I did negative 4. I don't have a y. I have a z, 0. First thing I'm going to do is do row 1 and row 2 to eliminate this. So I'm going to multiply row 1 by negative 7. Oh my. And row 2. And when I do these, the 7s will equal 0. So I'm going to have 1, 3. And then when I subtract, so that is going to be my new row 2. I'm leaving row. So I'm going to multiply row 1 by a positive 4. And then this will be 6 million. And then row 3 is going to be negative 4, 0, 1, and then 0. So 0, 4, 5, and 6 million. So when I look here, I'm going to want to do row 2 and row 3 to eliminate the y. So it looks like I'm going to multiply row 2 by a -4. And then row 3. And when I add those, I get 0, 0, -7. And then I'm sorry, I'm counting zeros. I don't want to make a mistake. So divide everything by -7 because I have those two zeros. I'm going to have 1, 600,000. So now my last. Now, when I did the answer key, because I do the answer key before I do this, I didn't look to see whether it said use, at this point here, I could use back substitution because it doesn't tell me whether I have to continue doing reduced row echelon. So I could do back substitution because I do have the ones, I have all the zeros below, and I could just back substitute in. But I did not do it that way, so I'm going to continue on with reduced row echelon. If you did it that way, just check and make sure your answers compare. I'm going to continue on for reduced row echelon, and I'm going to do row 2 and row 3 to eliminate this. So I'm going to multiply row 3 by -3, which is what you're going to do anyhow, but okay. So -3 times row 3 will be 0, 0, -3, and then I'm going to have row 2, which is 0, 1, 3. So now I have 0, 0, 1. And then I'm going to do row 1 and row 3. I'm going to do row 1 and row 3 to eliminate that y, so which means I'm just going to do -R3. Oh, somewhere along the line I dropped my dots. My bad. And when I do that, I get 1, 1, 0, and then 900,000. And then I'm going to do, the next thing I'm going to do is I'm going to do the opposite of row 2. So here's my new row 1. I'm going to do the opposite of row 2. I know I'm cheating. And I'm going to do 0, -1, 0, and then I'm going to have 1, 0, 0. So my final matrix in row echelon form will look like this. So what does this mean? That means I have 150,000 at 7%. I borrowed 750,000 at 8%. That's an at symbol. And I borrowed 600,000 at 10%. Now I'm going to go up and make sure the question doesn't ask me anything specific. Whoa, man, that's a long way up there. Solve the system using matrices. Okay, I did that. So that solves the system, and I hope this was helpful.